Elecard Boro is a professional solution for real-time quality monitoring of transport streams across distributed networks. It is used to monitor the stream quality in OTT and IPTV broadcasting and video surveillance systems. In this video, you will find a tutorial for the service administrator. We will explain what Elecard Boro is and how to manage a probe. Elecard Boro is a client-server application consisting of two parts, a software probe and a local or cloud server. Probes are distributed over the network, at the head-end station, at input streams monitoring points, and after transcoding, multiplexing, and encrypting modules. The probe receives streams, demultiplexes, and decodes data. The analysis is performed locally on the probe. The server receives statistical data only. The server processes and stores data, filters it through a notification system, and provides statistics in the form of tables and graphs. Boro supports Windows and many modern Linux distributions. A set of open ports is required for the solution to work correctly. Traffic between the probe and the server can be estimated at 10 kilobytes per second per data stream, which is per program, per media presentation, or per stream variant. The average traffic mostly depends on frequency of thumbnail capture and size of media playlist in HLS. The versions for Windows and Linux differ slightly from each other. Calculating Ethernet parameters requires higher privileges and installation of the Windows Packet Capture library. Ethernet parameters include the calculation of important metrics such as delay factor, media loss rate, inter-packet arrival time, and the source and destination addresses taken from packet headers. Some network controllers support hardware timestamping of received packets, which significantly increases measurement accuracy. However, it is usually not supported in Windows. PCAP recording requires elevated privileges when launching the probe. Records in this format can be invaluable for analysis of network incidents. On the screen, you see publicly available gigabit Ethernet controllers that support timestamping technology. The hardware method has different implementations. The most efficient one is per-packet timestamping. The probe automatically uses the hardware method if it is available. Another important feature of the network controller is support for receive-side scaling technology. This technology allows distributing intensive network traffic across multiple processes, reducing the number of interrupt calls, context switches, and cache cleanup. A low-cost network controller without RSS technology loses data at a certain bitrate. The whole load for controller interrupt falls on one core, although the other cores are free. The probe archive contains files needed to run the probe. The Stream Monitor executable file launches the probe application. The OSCI-pub file is the key to the project from which the probe was downloaded and allows the server to identify the data provider. The monitor configuration file stores configuration of each task that is assigned to the probe and some general settings. This file is used to restore the probe state after a restart. The file allows backing up settings, but it is better to use a special feature intended to save the settings on the server. General settings of the monitor configuration file include the proxy field, which allows probe to specify a proxy server to connect to the Boro server. For OTT tasks, the proxy server is specified individually in the web interface. This field allows downloading IPTV records in PCAP format. The service folder contains templates and scripts for running the probe as a service in Windows and Linux. The service allows running the probe at server launch in the automatic background mode. You can find more details in a separate video. The SNMP directory contains MIB files that describe the pattern for SNMP alerts. Let us take a look at the probe page. The top box contains information about the probe and the system on which it is running. Here you can restart or stop the probe. Note, if the probe is installed as a service and automatic restart is allowed, after stopping the probe from the web interface, the operating system automatically restarts it after the set time. The system resources of the probe are displayed in the right section. Here you can view the total CPU load and load distribution by cores. The probe application is constantly optimized so that the load is evenly distributed among the system cores. If one core is clearly overloaded compared to the others, it may be the one processing the network controller interrupts. Refer to the documentation to set up interrupts and select the most suitable controller. In this section, you can view available and used RAM size as well as the size of the hard disk partition from which the probe was launched and the amount of its use. Click Show NIC's usage to view a list of all available physical and virtual controllers, as well as the input and output bitrate. The notification system has a probe self-diagnostics. In the probe threshold settings, you can set the necessary alerts and resource overuse errors. You can also select which alerts are logged and specify their severity level. Hover over the marker to see a list of errors displayed. You can also view a summary page that displays information about all the running probes in the project. The page displays license stream usage information for both the entire project and individually for each probe. System information and resource utilization, including network activity, are displayed for the probes. You can update, stop, or restart a probe or a selected group of probes. To view the probe update history, left-click the probe version. Each probe has an event journal. The journal includes system events such as start, stop, update, and loss of communication with the server. In the journal, you can also view user actions that cause some system events. For example, a record that the user clicked the update button is created at first place, and then a probe update event appears. We understand that sometimes you may need help. Elecard has a support team as well as a business team that can help structure a solution for you. We are able to help address all your video monitoring and analysis needs for projects of any scale and complexity.